Hi folks, it's Bass Action back in action here. On this page of notes, we are going to look into our average rate of change, and we are going to start to apply and investigate the idea of secant lines. That's going to allow us to use our average rate of change with our secant lines, which will lead us eventually to our tangent lines. So just on this page, let's jump first into our average rate of change and a little bit of algebra review. We looked the other day at evaluating some functions that looked like this. So up here at the top under our warm-up recall, we did some review of this in algebra the other day. So I just want to practice that one more time before we actually jump into our average rate of change formula. So remember, what we want to do is evaluate the function at 6, subtract what we get at 4 when we evaluate at 4, and then our denominator of 6 minus 4. So using this given function of f of x, what I'm first going to do is evaluate that function for 6. So I'm going to get a 6 over, of course, 6 minus 3 is 3. I'm going to do a little bit of work in my head here. I'm going to subtract. My numerator will become 4. Then I'm going to do my 4 minus 3, or 1. That entire thing just following what I was asked to find. 6 minus 4 is 2. Cleaning that up a little bit, 6 over 3 is 2. 4 over 1, of course, is 4. That's all divisible by 2, which then leads me to a negative 2 over 2, and leads me to a final answer of a negative 1. Now, we're just going to kind of keep this idea in mind, and we'll come back to it in a moment. Now, our definition for today, our first idea, is average rate of change. So the important thing to think about with average rate of change is understand that average rate of change simply means the slope. It is simply the slope between 2 points. Now, we've done slope since we were in Algebra 1. What makes this interesting is that the formula for average rate of change is given right here, and what you'll notice is that this formula right here is actually the same thing that we just evaluated up above. So in our warm-up, we actually calculated an average rate of change. So let's break down this notation here. First of all, remember that f of b and f of a, those are really y values. So what we're really doing here is taking the difference between two y values. So a new notation that you might not be familiar with is the triangle mathematically is read change. So we can read this numerator as the change in y, and then our denominator, our b minus our a, those would be our x values. So we can think of this as the change in x. So you might want to write yourself a little note here that the triangle means change. That's what it's read, or change, or difference. So just in case you want to write yourself that note, change or difference. And C, E, sorry about that. Looks a little bit messy, but you probably got that there. E and C, E, difference. Now, so it's going to be our change in our y over our change in our x, specifically where we have to think about the fact that our a will not equal our b value. Now, I actually have this over here in a graphical representation as well, which is useful. So what we can see here is that we have 2 points. Okay, we have an x and an f of x, and a c and an f of c. We can think of this x and f of x as, for example, our b and an f of b, and our c and f of c we could think of as an a and an f of a. Okay, so let's jump into a formula here, and where it just specifically asks us to find an average rate of change. So it's going to provide us with a function, and then it tells us that it wants us to find this average rate of change from 1 to 2. Now, what you need to understand with this 1 and 2 is all that they're providing for us are x values. So they've only provided us half of an ordered pair, and they want us to find the slope. So what we need to do is we need to evaluate our function at each of those values. So I need to find f of 1, and I need to find f of 2. So just following my formula evaluating my function f of x for f of 1, I'm going to get a -2 plus my 1 equals my -1. And for my f of 2, I'm going to get 2 squared is going to be 4 times my -2, or a -8. I'm going to add to that my 2, just following my formula, and I'll get a -6. So now what I have here is I have an x value, and I have a y value, and I have an x value, and I have a y value. So now I can actually calculate my slope. Now I can calculate slope thinking the way I've always calculated slope, difference in my y's over difference in my x's, as we have indicated here, or I can think of it in our new notation, average rate of change, with our function notation. Either one is fine. So when we calculate slope, I can do -6 plus my 1, because remember I'm subtracting my negative, and I'm doing a 2 minus 1. So I get a -5 over 1, or I get a slope of a -5. So my average rate of change for this function right here is from 1 to 2 is a -5. Now, let's go ahead and take a look at a secant line, because we're going to apply this idea so you can understand a little bit more what this is actually telling us. So when we think about in our geometry classes about secant lines, what we understand from geometry, and if we're remembering that definition, is that a secant line, or I should say a secant is a line that's going to intersect a circle specifically twice. So what we're going to do is we're going to just think of a secant as just a line that intersects a graph twice. So we can look at our example 1, part A here. And we can think of our example 1, and we can visualize a secant line that intersects our graph twice. Okay. And you can see that I've actually put this graph, this line in here for us. Okay, so this curve that I have right here, this parabola, is in fact the same parabola if we chose to graph the function that I have up here in example 1 of y equals -2x squared plus x. I can confirm that it's the same graph because I can see my x-intercepts, which I could find mentally, so I know that. I know that my graph was supposed to be a downward turning parabola. So this parabola is the parabola that we looked at in example 1. Now the next thing that I've done for you is that I have graphed in a line that connects my points that I calculated from up above. So in example 1, I found that there's a point on the parabola at 1, -1, and I found that there's another point on the parabola at 2, -6. And then what I've done for you is I have graphed in for you the line through those 2 points. And what you can see is that line does in fact go through my graph in those 2 places, and it has a slope of a -5. So that graph has the slope of -5, 1, 2, 3, 4, 5, and over 1. So there's my slope. So what the average rate of change is telling us is that when we look at this graph of the parabola, what we know is that when we calculate slope, slope is for lines, but the average rate of change says that if I just focus on these 2 points of the graph and I connect them and imagine a line going through it, what is that slope? So in other words, about how fast is this part of the graph falling or changing? That's what average rate of change is telling us, is that we connect some values and allows us to give a change between those 2 points, even though it's not truly a line on the graph. Now, what we're going to do here, furthermore, is we're actually going to write an equation for that line that we've done. So we can think of our ordered pair as this 1, -1, but what we're going to begin to start to see more is they're going to typically write it in this notation, 1 f of 1, which we of course know that this f of 1 is the negative 1 as we calculated it earlier. I can write an ordered pair, write the equation of a line with that ordered pair by using my point slope form of a line. So I know 2 points on the line and I know the slope from up above. So I can say y plus 1, that's y minus the y value, and my slope is a -5, and my other point is going to be x then minus 1. If I want, I can clean this up, and I can say y equals -5x plus 5 minus 1, or y equals -5x plus 4. I can use the other ordered pair if I would prefer, so I could use the point from up above of 2 and f of 2 if I wanted to start with that notation that time, or I could translate it to its normal looking ordered pair, 2, -6. I can write that, the equation for the line through that point, so y plus 6. My slope is still -5, x minus 2. Rearrange that, -5x plus 10 minus 6, and you'll notice that we get the exact same equation. So it doesn't matter which point you choose, you should get the same thing either way. So that's our first introduction into average rate of change and how it allows us to understand a line passing through a graph and approximate how that graph is changing. So if you have any questions or if this was helpful, please let me know. And remember, it's always helpful if you subscribe to the page so that you don't have to find this over and over again. So we'll continue this discussion in class. Thanks.